Okay, today we are going to discuss absolute values 2.3 and the last learning outcome for this subtopic. Okay, so we're going to solve absolute inequalities, okay, of the forms as follows. So you can see these are the forms, okay, different forms of absolute inequalities. Okay, but before we discuss how to solve absolute inequalities, so let's recall the definition of absolute inequalities. So we can see the third definition here. Okay, so when we have absolute inequality, so there are two types of inequalities. So first you can have the greater than sign, okay, and also we can have less than sign. So for these two different signs, we are going to have two different definitions. So okay, as we can see, if you have absolute of x greater than a, greater than a, okay, when a is any number, then the definition will be x greater than a. So we just copy back the inequality sign, greater than a, and then next we change the inequality sign, less than negative a. Okay, but please bear in mind, when we have greater than sign here, so we are going to have union, okay, or union also represented by the word or. Okay, and then if we have the absolute to be less than a, so okay, we define the inequality as x less than a, and then x greater than negative a. And then here, if you can see, when we have this less than sign, so we are going to have the operation of intersection, and intersection is represented by the word and. So now how to memorize this definition. So as you can see here, we do have this gola. So this gola means you have, if you have greater than sign, okay, so G stands for greater. If we have greater than sign, so we are going to use or. Okay, so G stands for greater and O stands for or. Okay, which means we are going to use union. And then when we have less than sign, okay, so this L stands for less and the A stands for the word and. Okay, so we are going to have intersection. So we have gola, greater or, less than. Okay, so now let's discuss the first type of inequality, absolute inequality. Okay, so we are going to have the first example. Okay, so this first example will discuss, okay, the first form of this absolute inequality. So let's say if we have absolute of 3x plus 5 greater than half. Okay, so again we define. So first, in order to use the definition, so please bear in mind this is greater than sign. So if you have greater than sign, we're going to use or. Okay, so first we define 3x plus 5 greater than half, or 3x plus 5 less than negative half. Okay, so after we split into two, so we can see that we do have two linear inequalities. Okay, so now let's try to solve one by one. Okay, so we will have 3x greater than half minus 5, which will give us negative 9 over 2, and we have x greater than negative 3 over 2. And again, we still have this or. Okay, and we solve the second linear inequality. So we have 3x less than. Okay, so we bring the 5 to the right. So we have minus 1 over 2 minus 5, which will give us negative 11 over 2. And then x is less than negative 11 over 6. Okay, so now in order to find the union between these two sets, so what must we do is we are going to draw number line. Okay, so between negative 3 over 2 and negative 11 over 6, so we do have negative 11 over 6 to be the lowest value, then followed by negative 3 over 2. Okay, so based on the first set, we have this greater than negative 3 over 2, empty circle to the right, and then next we have negative 11 over 6 to the left. Okay, now we are going to find the union. So union means we consider, also we shade the respective region. Okay, and now we can finalize our answer. Again, the answer can be either in solution set or interval form, okay, unless stated otherwise in the question. So now let us use interval form to finalize our answer. So you have negative infinity, negative 11 over 6, union with negative 3 over 2, infinity. Okay, for the second type of absolute inequality, okay, so we are going to see the second example. Okay, so whereby we do have, if you have absolute on one side and we have linear expression on the right hand side. Okay, so how are we going to solve this? Alright, so we do have absolute of 5 minus 4x less than 2 over 3x plus 1. Okay, but so we are going to use the same definition. Okay, so if you can see here, this is less than sign. So which means we are going to use this law, which means if less than sign, we are going to have n, okay, in between. So we write this down. And okay, now how to define the absolute inequality? So first we are going to have 5 minus 4x less than 2 over 3x plus 1, and we have 5 minus 4x to be greater than negative of 2 over 3x plus 1. Okay, so now let's solve these inequalities one by one. Okay, so again, they will become linear inequalities. So, okay, we will have, okay, we bring the negative 4x to the right and we bring the 1 to the left. So what do we have here? We will have 4 less than 2 over 3x plus 4x, which means we are going to have 14 over 3x. Okay, and then we cross multiply the constants, so we will have x greater than 6 over 7. Okay, and now let's solve the second linear inequality. Okay, so first thing first, we expand the bracket, so we have greater than negative 2 over 3x minus 1. Okay, and then we move this negative 4x to the right and negative 1 to the left, so we will have 6 greater than, so negative 2 over 3x plus 4x will give us 10 over 3x. And then again we cross multiply, so we multiply 3 by 6 and divide by 10, so we have 18 over 10, which means 9 over 5, so we will have x less than 9 over 5. Okay, so now we need to find intersection between these two. So how do we do this? So we need number line to help us. So we draw number line. Okay, 6 over 7 is smaller than 9 over 5. So here we will have, okay, 6 over 7 to the right. And then we will have 9 over 5 to the left. Both empty circles. And now let's find the intersection. Okay, so when we find the intersection here, so we will have the answer to be, okay, between 6 over 7 and 9 over 5. Okay, now for the third type, okay, of absolute inequality with absolute on one side. So now, okay, we do have rational on the rational absolute on the left hand side. Okay, so let's see an example to this. So what if we have absolute of 3 minus x over x minus 5 to be greater than 3? Okay, so please bear in mind here we do have greater than sign, so which means we are going to use this definition. So if we have greater, then we're going to have or. So now let's define this rational, absolute rational inequality. So we do have 3 minus x over x minus 5 to be greater than 3, or we have 3 minus x over x minus 5 less than negative 3. Okay, so now after we split into 2, so they have become rational inequalities. Okay, so we discussed before, okay, how to solve rational inequalities is by solving using sign table. Okay, so now since we do have two rational inequalities, so we are going to have two sign tables. Okay, so first let's solve the rational inequalities one by one. Okay, we focus on the first one first. So first step, okay, we must make sure that the right hand side is always 0. So what do? We bring the 3 to the left hand side. Okay, so we have minus 3, and then next we need to ensure that the left hand side is a single fraction, so we are going to equalize the denominator. So we put here 3, okay, x minus 5 and x minus 5 here, and then we expand the bracket, so we will have 3 minus x minus 3x plus 15 divided by x minus 5. Okay, then what's next? Okay, we simplify the numerator, so we will get 18 minus 4x divided by x minus 5 greater than 0. Okay, and we set condition that the denominator cannot be 0, thus the x cannot be 5. So now we find critical values. So critical values, okay, are found if fx is 0 and fx undefined. Okay, so fx 0 means the numerator will be 0. Fx undefined means the denominator will be 0. Okay, so now let's find critical values. 18 minus 4x equals 0. So 4x equals 18 and x equals 2, 9 over 2. And next, okay, we find the second critical value. Okay, so we will have x minus 5 equals 0 and x equals to 5. So we have two critical values. So 9 over 2, we do have 4 over 5, right? 4.5. Okay, after we get the two critical values, we arrange them on a number line. So 9 over 2 comes first before 5, and then we draw table. Okay, since we do have two critical values, so we will have three different regions. Okay, so we will have negative infinity, 9 over 2, 9 over 2, 5, and 5 infinity. And we bring the linear factors down. We have 18 minus 4x and x minus 5. And the conclusion. Okay, so now how to fill in the table with signs. Okay, so we see 9 over 2 is the root of 18 minus 4x, so we will get 0 here. And please bear in mind, okay, the sign of x is negative, so we will have all negative signs on the right of 0 and positive on the left of 0. And 5 is the root of x minus 5, so we have 0 here. And because the sign of x is positive, so we will have positive here and negative on the left of 0. And then we may find the conclusion, positive divided by negative, negative, positive, and negative. And lastly, which sign do we circle? Okay, because we want greater than 0, so we circle the positive sign. So which means, okay, we have answer 9 over 2, 5. Okay, so this is the answer for the first sign table. Okay, now we need to solve the second rational inequality so that we can get the answer, and later we will find the union. So what do? Okay, we solve the rational inequality here. So for this one, okay, we bring the negative 3 to the left hand side, so we will have 3 minus x over x minus 5 plus 3 less than 0. So we equalize the denominator. Okay, and then we expand the bracket, so we will get 3 minus x plus 3x minus 15 divided by x minus 5 less than 0. Okay, then we simplify the expressions. We will have 2x minus 12 over x minus 5 less than 0, provided that again x cannot be 5. So now find critical values. So we will get 2x minus 12 equals 0, x equals to 6, and x minus 5 equals 0, x equals 5. Okay, so we have two critical values. We may now draw a number line. 5 here followed by 6. So we may draw sign table. And here we have negative infinity 5, 5, 6, and 6 infinity. And we write down the linear factors. So we have 2x minus 12, x minus 5, and the conclusion 2x minus 12 over x minus 5. Okay, now let's fill in the table with the signs. So 5 is the root of x minus 5, so we get 0 here. So positive on the right and negative on the left. And 6 is the root of 2x minus 12, so we will get 0 here. So positive on the right and negative on the left. So let's find the conclusion. Positive, negative, positive. And which sign should we circle? So we are looking for negative sign. Okay, so we have the answer to be 5, 6. Okay, we get the answer here, but don't forget, okay, we are not done yet because we need to find union between these two sets. Okay, why? Because initially we define the absolute inequality, and we have written the or means its union. Okay, now in order to find the union between these two sets, we draw a number line. Okay, so we have this 9 over 2, we have 5 and 6 here. So okay, we draw this line to represent the first set, and then we draw this empty circles to represent the second set, and we need to find the union, means we consider all. So the answer will be two sets here, so we just copy down back. So we have 9 over 2, 5, and union with 5, 6. Okay, for the fourth type of absolute inequality with absolute on one side, okay, so we are going to have this absolute inequality with quadratic expression, okay, inside the absolute. Okay, how do we solve this? So actually the same thing, we use the definition. Okay, and now let's see an example to this one. Okay, so let's see example. If you have absolute of 4x squared minus 8x plus 3 less equal 1. Okay, so please observe the inequality sign in this example. It's less than sign, so which means we are going to use this definition. So we are going to have the word and here in between. Yeah. Okay, so now let's define the inequality. So we have 4x squared minus 8x plus 3 less equal 1, and we have 4x squared minus 8x plus 3 greater equal negative 1. Okay, so after we split into 2, so you can see that we have two quadratic inequalities. So which means, okay, we are going to use graphical method in this case to solve the quadratic inequalities. So now let's solve them one by one. Okay, so we bring here 1 to the left hand side. So what will we have? So we will have 4x squared minus 8x plus 2 less equal 0. Okay, and we divide both sides by 2. So we will get 2x squared minus 4x plus 1 less equal 0. So in order to solve this, okay, we let this quadratic to be 0. Okay, so if we try to press calculator or if we try to do manual factorization, we will see that this quadratic cannot be factorized. So in order to find the roots, okay, so it's either we use completing the square or we use the formula. A equals 2, B equals -4, and C equals 1. So by using formula, x equals to -b plus minus square root of b squared minus 4ac divided by 2a. So now substituting the values of a, b, c into the formula, so we will have negative of -4 plus minus b squared -4 squared minus 4ac divided by 2a. So we will have 4 plus minus 14 squared is 16 minus 8 divided by 4. Okay, and because we know that 16 minus 8 will give us 8, so square root of 8, okay, we will get 2 sub 2. So we write down this 2 sub 2 divided by 4. So okay, so we divide this by 2, so we will have 2 plus minus 2 over 2. So these are the roots, hence we may now sketch the graph. Okay, so we sketch the quadratic graph. So we will have 2 minus 2 over 2 and 2 plus 2 over 2, and we shall consider the less than sign value, so that means we have to shade this region below x-axis. So we will get the answer to be 2 minus 2 over 2 and 2 plus 2 over 2. Why do we have square brackets? Because we can see there is an equal sign here. Okay, so that's why we consider the close bracket. Okay, so now let's solve the second quadratic inequality. So we will have 4x squared minus 8x plus 4 greater equal 0. We divide both sides by 4, so we will have x squared minus 2x plus 1. So we let this to be quadratic equation first, and then if we try to factorize, so we will get 2 equal roots. Okay, so which means x equals to 1 only. Okay, so if we draw the graphs, so we will have this quadratic graph intersecting x-axis at one point only. Okay, and now we need to consider the region above x-axis, so which means we consider all the regions here above x-axis. Okay, so we consider all values, so which means the answer will be, okay, all real numbers. Okay, but we are not done yet because we need to find the intersection between the two sets. We need to draw number line. Okay, so when we draw number line, so we have 2 minus 2 over 2 and 2 plus 2 over 2. Okay, so we have this set intersect with all real numbers. So we may find that the intersection will be this single set here. So which means the answer will be 2 set 2. Sorry, this should be done circle because we have close brackets. So 2 minus set 2 over 2 and 2 plus set 2 over 2. Okay, so now for the last form of absolute inequality, when we have absolute on both sides, so we are not going to use gola. Why? Because gola is only when we have absolute on one side. Okay, so now when we have absolute on both sides, so what do? Is we are going to use this definition. Okay, we express absolute of x as square root of x squared, and then we are going to get rid of the set by squaring both sides. Okay, so now let's see an example. If we have absolute of 7x minus 2 over 3, okay, less equal absolute of 8 minus 2x. Okay, now, okay, by using the definition of absolute, so we have absolute of 7x minus 2 is basically 7x minus 2 over 3 squared. Okay, and the inequality sign will remain. So here we will have 8 minus 2x squared. Okay, now in order to get rid of both, okay, the sets on both sides, so we simply square both sides. So by squaring both sides, so we can eliminate the set. So we will get 7x minus 2 over 3 squared less equal 8 minus 2x squared. So what do? We are going to simply square both sides. So we will have 49x squared minus 14 minus 14, so minus 28x plus 4, okay, over 9 less equal 64 minus 16 minus 16 minus 32x and plus 4x squared. Okay, and then we bring the 9 to the right. Okay, and then we simplify, so we will get x squared plus 20x minus 44 less equal 0. So we are going to we are going to get this quadratic inequality. So we solve this quadratic inequality by using graphical method. So first we let this to be 0 so that we can find the roots. So we do factorization, x minus 2, x plus 22 equals to 0, hence x equals 2, x equals negative 22. So after we get the roots, we can now draw the graph. So we will have negative 22 here and 2 here, and we shade the region below. Why? Because it's less equal 0. So now the final answer will be negative 22, 2.